Hello everyone, my name is Rutuja Sanjay Mali, a final year electrical engineer student from Patel Institute of Technology Shirpur. I recently completed a 1-month internship at Emertxe Information Technology Private Limited, Bengaluru, one of the India's top embedded system training institute. Today I will be presenting my learning and experience through a project titled Washing Machine with Embedded Control. This internship have experience in the embedded system which has duration 1 month. Here is a quick overview of what we will cover and what I have learned in this internship, starting from the basics of embedded system, followed by key components, microcontroller architecture, tools and simulators use, peripherals, and finally a deep dive into my washing machine project and what I have learned from it. Next one is what are embedded system? A specialized computer system designed for dedicated function within a larger system. So it's used to perform a specific task such as controlling machines, managing sensors, or automating systems. Next one, components of embedded system. Embedded system have various components like microcontrollers and microprocessors, which is the core processing unit, memory like RAM, ROM, flash to stores the program code and data, input and output devices like sensors, switches, displays and actuators. It has power supply and clock circuits which provides stability and synchronization, and communication interfaces. Next one is what is a microcontroller? A compact integrated circuit designed to control a specific function known as a microcontroller. Is a compact IC designed to govern a specific operation. It has features CPU, memory, IO ports, timers, communication interfaces. Next one is microcontroller architecture. It has two main architectures, von Neumann architecture and Harvard architecture. Von Neumann has features like uses single memory for program and data storage, sequential instruction execution, simpler design but slower due to memory bottleneck. Harvard architecture has separate memory for program and data storage, parallel instruction execution and faster performance, which is commonly used in embedded system. Next one is MP Lab IDE and development environment. So during an internship we use MP Lab IDE, a complete toolchain for PLC microcontrollers. The XC8 compiler was used to compile C code, and PIC Pixin Lab help us to simulate our embedded project. So PIC 16F877 microcontroller overview. It has architecture that 8-bit RISC architecture. It has feature with 33 IO pins, multiple timers, ADC, SPI I2C communication and UART. It has various applications like motor control, industrial automation and sensor interfacing. This is the picture of this microcontroller, which is 16F877A PIC model. Next one is peripherals used in the project. So there are main three peripherals that I have used in my embedded program. So first one is switches and keypads, timers and buzzers, CLCDs and displays. So this plays various roles in my project to run my project effectively. It also plays and have. Next one is ports and pins, IO configuration. So it has various ports GPIO, which is general purpose input output ports, pin mapping for PIC 16F877A microcontroller, configuring digital and analog input output. So this microcontroller has 33 pins. Matrix keypad interfacing. A matrix keypad consists of rows and columns forming multiple input keys in a compact design. It has working principle like each key press completes a circuit between a specific row and column. It has scanning method, it using a row and column scanning techniques to detect the key presses. It has application in ATM machines. Tactile switches in embedded system. Tactile switches are mechanical switches that provides a physical feedback click when pressed. It has working like when pressed, the switch closes the circuit and registers an input signal. It has application like control panels and remote controls and industrial automations. By using GPIO pins, it interfaces with microcontroller. This is the image of tactile switches. Next one is interrupts in embedded system. Interrupts allow microcontrollers to respond to external or internal events immediately. It has two types, external and internals. External triggers by external events and interrupts triggered by timers, ADC conversions or communication modules. Next one is ISR, interrupt service routine, a special functions that executes when an interrupt occurs. It also has various applications, real-time applications like motor control, sensor monitoring and automation. In embedded system. Next one is timer in embedded system. Timer generates the time-based delays and event triggers. There are two timer modes, timer mode and counter mode. Timer mode counts clock cycles and generates precise delay, and counter mode counts external events such as pulses from a sensor. Interfacing with PIC 16F877A like using timer 0, 1 and 2 for different applications. Timers also have various applications in embedded system using motor speed control, periodic data logging and signal generation, which plays very crucial role in various projects in embedded system. Next one is prescaler and post-scaler in timers. So prescaler divides the input clock before feeding it to the timer, and post-scaler divides the timer overflow output before generating an interrupt. It has significance that it helps to achieve precise timing intervals without requiring high-speed clocks. Example of implementation of prescaler and postscaler are configuring prescaler values in timer 0 to achieve different delay durations. Next one is LCD interfacing in embedded system. So it has definition like an LCD, which is full form is liquid crystal display, is used for visual output in embedded application. The common LCD types are 16 by 2 characters LCD, also 128 by 64 graphical LCD, and I have used him in my project which is 16 by 4 character LCD. So interfacing with PIC 16F877 like using 4-bit and 8-bit mode to send data and commands. It also has various applications using GUIs, industrial displays and monitoring system. This is the common example which is 16 by 2 LCD. Next one is key learnings. So in this internship I learned hands-on experience in embedded C programming, hardware interfacing techniques, debugging and problem solving skills and the confidence to develop real-time applications using microcontrollers. And from this, I have designed my project. Next one is I2C communication in embedded system. So I2C is a two-wire communication protocol and it uses SDA and SCL, which is data line clock line, for synchronized data exchange. In this, each device on the I2C bus has a unique address and it has applications like EEPROMs, temperature sensors, and real-time clocks. It also plays various roles. Next one is EEPROM, electrically erasable programmable read-only memory. It is a type of a non-volatile memory used for storing data. It has features like it retains data even when power is lost. It interfaces with microcontroller like using I2C or SPI to read and write data. It has also have various applications like using configuration storage, data logging, and firmware updates. The next one is watchdog timer in embedded system. Watchdog timer is a timer that resets the system if it hangs or crashes. It has importance like it prevents system failures and ensures reliability. It configured in PIC microcontroller, which is enabling watchdog timer setting time out period and clearing watchdog periodically. Applications like using industrial automation, medical devices, and critical system. I have also used in my project. So the next one is washing machine project overview. So let's dive into my final project, washing machine controller. It has objective lies automate the wash cycle using a PIC controller. It uses microcontroller which is PIC 16F877A and components like microcontroller, 16x4 LCD, keypad, relays and drivers, motors, buzzers, water level sensor, cooling fan, heatsink, and power supply. These are the various components I have used in washing machine. Let's see the working principle. So the working principle of this project is user select the wash program. Using the keypad, the microcontroller reads the input, initiates the wash cycle, controls the motor, water flow, and buzzer via relays and timers, and the LCD updates the user with current status, and the cooling system keeps the driver operating safely, which is fan or heatsink to cool the motor drivers and ensures stable performance. So thank you. Now I want to demonstrate my project, which is washing machine project based on embedded system. So let's dive into my project, which is washing machine, demonstration of washing machine using MPLab and PIXimLab. I developed this project using MPLab IDE software. Let's open it. So this is the washing machine project. This is the sources and header files. Header files like CLCD, digital keypad, main, timer, washing machine. Also there are sources files with .c. I have already choose the microcontroller which is I have shared. So run the project. So build successful. It shows no error. So let's is load on Pixim Lab, which is a virtual microcontroller for PIC 16F877A. I have already selected here. So let load the hex file of washing machine into the microcontroller. I have selected the LCD which is 16 by 4, clock frequency 20. So press key 5 to power on washing machine. So the keys are 1, 2, 3, 4 and 5. So let's press key 5. It will open powering on washing machine screen. After some delay, it will turn on the screen which is washing machine program screen. It has various options like daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. So let's long press the key 4 to change the screen and select the aqua store. After some delay, water level screen will be open. It also has various options: auto, low, medium, high, max, again auto. So let's select the auto, long press the key 4 to change the screen. Again the stop and start screen is occurs after some delay. So to start, press key 5. The countdown timers start. We have already on buzzer and cooler fan. Let's press the long press key 3. It will show please close the door and it resumes there. Again starts where it stopped. So we can press key 5 to start and 6 to pause. So let's press key 6. It will stop here, and when we press key 5. So then it will resumes from where it was stopped. So it count down the time and program completed, remove clothes, and at this time buzzer is turn on. So again washing program screen is occurs. Let's select heavy by pressing key 4, which will change the screen. After some delay, water level screen is arrives. Select low level by pressing key 4, long press. Then it will change screen. Again start and stop. So let's select key 6 to stop the program. It will back the program to the again washing machine screen. Let's select again the heavy option. After some delay, it will again show the water level screen. Let's select the max option, long press key 4. Again start and stop screen. So let's start by pressing key 5. Again the timer countdowns the time we have set. Again press key 3, which will shows please close the door, and buzzer turn on at that time. And we will release this. Press key 6 to pause the program, and 5 to again resumes where it was stopped. So in this we have used countdown timer, watchdog timer. Wait until the timer ends. Remove clothes. Program is completed successfully. So thank you. I have demonstrated my project, which is washing machine, by using PIC lab. I successfully run this program by learning things from this internship. So thank you.